Hello and welcome. I'm Teacher Walton. Today we'll be looking at the first worksheet in number theory and computation as we prepare for exams. So we begin with the reading of God's word, which is taken from 2 Chronicles chapter 4, verse 10. This is the King James Version, and it says, "And Jabez called on the God of Israel, saying, Oh, that thou wouldest bless me indeed, and enlarge my course, and that thine hand might be with me, and that thou wouldest keep me from evil, that it may not grieve me. And God granted him that which he requested." So this is my declaration. I say, God will bless me indeed and enlarge my course, and his hand will be with me. The Lord will keep me from evil, that it may not grieve me. Amen. So today's question, as we begin this revision course, courtesy the Math Ministry at www.maths123.org, we begin with question number 1, which is asking us to write a couple decimal numbers as fractions. So the very first question says write 0.35 as a fraction. Now, when a number is given in decimal format, look at the number of digits after the point. So we see 2 digits here. So if you are writing that number as a fraction, there are 2 digits after the point, and that tells a story. What is the story? This will be the number of zeros we must put in your denominator. And of course, we're going to write the whole number 35 in our numerator. So let's say that again. The number of decimal places or number of digits after the decimal point will tell you how many zeros you put. Always write 1. And you have 35, so you just put the whole number format in your numerator. So as a fraction, it's 35 divided by 100. Now, if you wish, you can simplify this. 5 can go into 100 20 times. 5 can go into 35 7 times. So your answer will be 7 over 20. It's always a good idea to learn our multiplication tables so we'll know how to do our division. Now, let's try this again for the second question. How many numbers, not numbers, how many digits do we have after the decimal point? We have 1, 2, 3, 4. So it means that we'll write our 1 and 4 zeros. 1, 2, 3, 4. And then we write the whole number, which is simply 36. Notice the zeros in front of 36. Those zeros are not added. So in other words, we'll not write 0, 0, 36. We simply take the whole number, which is 36. So 36 divided by 10,000. 4 can go into 36 9 times. 4 can go into 125. So this will be 2,500. So the answer will be 9 over 2,500. In question number 2, we are asked to write 4.096357, correct to 1 decimal place. And when they ask you for 1 decimal place, you look at the number of digits after the point. So you're looking at 1 digit after the point, which is a 0. And I always tell my students to draw a cut-off point as a line. And this is the rule. If the next digit, which is a 9 here, is 5 or more, you add 1 to the preceding digit. So let's do that again. The number is 4.096357. You ask to write it to 1 decimal place. You count 1 digit after the point and you put a line, and then you look at the next digit that follows, and if it is 5 or more, you will add 1 to this. So therefore your answer to 1 decimal place becomes 4.1. Let's try it to 2 decimal places. So we write our number 4.096357. 2 decimal places mean that we are drawing our line after this second digit, 1, 2, draw our line right here. And we examine the digit or the number, the digit after that line, which is 6. It's more than 5. So we're going to add 1. So 9 plus 1 will give us 10. So the answer will be 4.10. And let's look at the third one, 3 decimal places. Again, we write 4.0936357. And we have our cutoff line after 3 digits, 1, 2, 3. So the cutoff line comes here. And we say if it's 5 or more, you add 1. In this case, it is not. So therefore, you leave the number as is. So this answer will be 4.096. Question number 3. Write the number 4.096357 correct to 1 significant figure. So the significant figures, that's another way of approximating, as we just saw there with our decimal places, writing the number to a given number of decimal places, we are approximating those numbers. When you ask to write correct significant figures now, let's see how that works. So if you have the number 4.0966357. Now, if they say 1 significant figure, you simply count your digits. So this is 1 right here. That's a 4, 1 significant figure. And you do the same thing. You look at the next digit. And if that digit is 5 or more, you add 1. If it is less than 5, you leave it as is. So it is 0. So it means that the answer here will simply be 4. Let's write it to 2 significant figures now. 4.096357. Now this time we are counting 1, 2. We pull our line there. And we examine the next digit, which is the 9. And therefore it's 5, it's more than 5. So we're going to add 1 to the preceding digit, which is the 0. So our answer becomes 4.1. Let's go to the third one, 3 significant figures. So we write the number 4.0966357. Let's count again, 3 significant figures, 1, 2, 3. Notice that you still have to count that 0, right? In this case here, you must count it. So it's 1, 2, 3. And we will pull our line right here. And of course, we examine the next digit, which is the 6. It's more than 5, so we'll add 1 to this 9, and it becomes 4.10. Now, let's compare these two answers. Notice 4.10 is 2 significant figures, 1, 2. They ask for 3, so we cannot write the answer as 4.1. We must include that 0 at the end there, because it's 3 figures they want, or 3 digits, 1, 2, 3. So this one will not be correct. You must put in that 0 to give us 4.10 to 3 significant figures. Now, I've given you in question number 4 a similar question, but your number begins with some zeros, and this is important. Where you have a decimal number beginning with 1 or more zeros, you do not count the zeros when you are starting to count your number of significant figures, and I'll illustrate that. Now, in this example, we began with 4. So this one was a non-zero, which was 4, but here we are beginning with a few zeros before the first non-zero number, which is 8. When I say non-zero, I simply mean that the digit is not a 0. So that is where we begin counting. So if we want to write this to one significant figure, we are looking at starting our count from the 8. And therefore our answer, of course, we look at the next digit after the 8, which is a 4. So our answer here will be 0.008. Since it's a 4 that follows the 8, we do not add 1 to our 8. Let's go to the next one, 2 significant figures. So we are writing this. 2 significant figures. We start our count here. So it will be 1, 2, pull our line right there, and it's exactly 5. So we'll still add 1 here. So our answer now will be 0.008. 4 plus 1, 5. And let's go to the last one, 3 significant figures. Where do we begin counting? From the first non-zero digit. So you want 3, 1, 2, 3. Pull our line right there. And the next digit is more than 5. So we will add 1 to this last digit, which is a 5. So answer becomes 0.00846. So bear that in mind. When you're asked to write correct a certain number of significant figures, simply ask yourself if the number we are looking at starts with a set of zeros, 1 or more zeros. If not, as we saw with 4.09635, we begin with the first non-zero digit. All right, so that'll be a nice rule to write down. Always begin your counting from the first non-zero digit in that number. Okay, let's go to question number 5. Now, this one is a very interesting question. It asks you 4.08, how can we write that? So what we need to recognize is this 408. Let's occupy the position of each digit in our table. And this table is called your place value table. Now you'll be given a worksheet similar to the one I'm working here. So you'll be able to practice solving some of these questions. So we want to write 408. Now, just as a reminder, this is our units position. This is our tens. And this is our hundreds. Right. Now, a couple of things I like to tell my student. 100. So this will be 4 by 100. So the value of that 4 is really 400, right? We've seen it right here. It's 400 plus 0 tens. You could still write it 0 by 10. And then we add in 8 units or 8 by 1s, 8 ones, 8 by 1. So we have just expanded this number 48 and write it as 4 by 100, 0 by 10, and 8 by 1. The way you write the number as shown here is called writing that number in expanded notation. So let's see what's happening now. Now, the question has 10 cube, 10 square, and so on. So it is now asking us to remember that 100 is really 10 square. 10 is understood to be 10 by 1, and 1 is 10 to the 0. So we've seen some patterns here. 10 to the 0, 1, 2. So let's write that as a note here. The 100 occupies the 10 square position. That's 100. The 10s would be 10 to the 1. And the units, we can simply write it as 1, but I'm just showing you it's also equivalent to 10 raised to the power 0. That's something you'll need to remember later on. Now, just for example's sake, if it was a 5 here, of course, we'll put 10 cube. And this now would be 5,408. So it will be 5 by 10 cube, which is really 1,000. This will be a thousands position. After 100 is thousands. So I'm just illustrating this. And of course, this would be 10 cube here. Now, I'm going somewhere with this. So let's focus on the problem at hand, which is really this part. 4 by 100 is really 4 by 10 square. 0 multiplied by anything, although it is 0 by 10 to the power 1, 0 by anything has a value of 0. And our 8 by 1 is simply 8, right? So we could write it as 8 by 10 to the 0, but it is still 8 by 1, which is really 8. So what's our final answer? It will simply be 4 by 10 square plus 8. 0 has no value, so we need not include it there. So let's see if we have an answer resembling that. Here it is, 4 by 10 square plus 8. And let's see if we can wrap up with perhaps our final couple of questions here. Okay, so we are asked now to write some questions in, well, this is part of the last choice, part D, so that will be out. And let's go to question 6. Write this number in standard form. If you recall, writing a number in standard form means you must have a number here, which must always be between 1 and 10. Right, let's put a little note here, between let me say from 1 up to, but not included. So it cannot be a 2-digit number. It cannot be 10. It can be 1. That's why I say from 1. So it could be from 1, for example. This could take the number 1. And the other part of it, 10, raised to some number up here, right? And this number here could be an integer. I don't know if you remember what an integer is. The set of integers would be numbers like negative 4, negative 3, negative 2, negative 1, 0, 1, 2. So, and so on, right? So those are integers. So let's go back to the question at hand. We need to write it in this format. An example, if you are using 1, would be, an example if you are using 1 would be like 1 by 10 square. That's an example of standard form. Now, how do we tackle this question given? First of all, let's make this number a number between or from 1 up to, but not including 10. To do that, you put your point right here, 5 point something. Are you seeing that? So let me write it better for you. So if we given this number 5078, and we want to write that in standard form, the first thing you do is you put a point right here. So we are making that a number between 1 and 10. Could be 1 as well if that was the case, right? So what next? To get back this whole number, it means at this point we'll have to move 1, 2, 3 places to the right. Now, if you are moving that point 3 places or how many places to your right, you simply put the number of places you are moving, but this number up here will be +3, positive. So what do I mean? So if you move into the right, you use a plus sign, as we see in here, 1, 2, 3. Now, your final answer will look long, something like this, 7, 8 by 10 to the 3. Notice +3 is the same as 3. So that is your answer in standard form. Let's do another one. But this time we're going to be moving to the what? To the left. And once you move to the left, it will be a negative sign that will be used there. Okay, let's look at the second question here. So 00687, right? So if we are writing this number 0.00687 and we want to make it a number between 1 and 10, the point must go between the 6 and the 8 to make it 6.87. So that's the first part. That's the A value. We got that first part right. So we must multiply this by 10. Now notice we need to count the number of places. Let me write it here. Count the number of places. So if I have 0.00687 and I put my point here, right here, that's what I did, 6.87. I am now moving to the left. Let's see, 1, 2, 3 places to get back my original number. So I'll put a 3 here, but since I'm moving to the left, it must take a minus sign. So that's the difference. If you are moving to the right, count the number of places you are moving and use a plus sign with the number of places you counted. If you are moving to the left, same thing. Instead, you use a negative sign. And that's how you write it. And finally, yes, finally, what is great? We are asked to evaluate these two numbers here. Now, what I would like to indicate to you in that last example, you would notice this first part of the sum, 2.3 by 10 square, that is written in what? Standard form. But the second part, watch it carefully, is not written in standard form. Can you tell me why? Remember we said the first number, must always be between what? From 1 up to 10, not including 10, it can be a double-digit number between 1 and 10, inclusive of 1. And you'll notice the first number in the second part is 512. So that cannot be what? Standard form. Okay, now the question asks us to work out, simplify, evaluate that expression and give our answers in standard form, give our answer in standard form. So let's do just that. So if you are given 2.3 by 10 square, so a couple of ways we can do this. Let's try this one first and see if it works. So 10 square means what? You are moving that point 2 places to the right. 1, 2. So you'll add a 0 right here. So 2.3 by 10 square is really 230. There you go. And let's try this one. Notice the point is understood to be right here this time. It's 512. It's a whole number. So the point is understood after the 2. And we are moving this, how many places? 2 places, but because it's a minus sign, you're moving this point 2 places to the left. 1, 2. So this is equivalent to 5.12. So really and truly, you're adding 230 to 5.12. And that will give us 235 0.12. Now, this is not in standard form. If we are writing this in standard form, you position the point so that this number is between 1 and 10. So it's 2.35. And then you count the number of places you'd like to move it to get back the original number, which is this. Notice you're moving 2 places to the right. So in standard form, your answer will be 2.3512 by 10 raised to the power 2. So that is important. That's how you work your standard form. And that is where we'll end it. God has been good. So I just want to thank you for taking the time to look at this video. And I'll see you in the next one. Look out for the worksheet on the website, www.maths123.org. Bye for now. I'm Teacher Alton. Take care.